To help describe R1 like you asked, we'll focus on DeepSeek R1, a smart thinking machine. Imagine it like learning to solve puzzles. It's built using a method called reinforcement learning, which means it gets better by trying things out. It took big steps forward from something called DeepSeek R-1 Zero, which was already good at figuring things out. Before it starts learning through practice, it uses what we call cold start data, like getting a little help at the beginning. As a result, it's just as smart as another thinking machine named OpenAI O1 1217. DeepSeek R-1 Zero is a bit like a little thinker trying to get smarter with lots of practice. It uses something called reinforcement learning, which is like learning from its own tries without any special help to get going. This helps it figure out how to think better all by itself, like knowing when it might have made a mistake and trying to fix it. If we look at the picture, it shows how its accuracy gets better over time as it tries more and more. The lines go up as it learns more, showing how practice helps it improve. But it sometimes finds it hard to read things clearly, almost like when letters get jumbled up in a storybook. DeepSeek R1 takes a step forward by using something called cold start data. Think of it like when you start a new game and get a tiny nudge to help you begin. It helps DeepSeek R1 keep steady as it starts to learn. It mostly works on puzzles about coding and logic, making it like a problem-solving expert. To make sure it really understands, it uses two special tricks called rejection sampling and supervised fine-tuning. Imagine it like getting extra practice to be sure of what it knows. After that, there's another round of learning called a secondary reinforcement learning stage. It's like a second round of polishing to make DeepSeek R1 super helpful and avoid any mistakes. If we look at the formula, it shows the careful and precise calculations DeepSeek R1 does to get better at each step, balancing each piece like a smart jigsaw. DeepSeek R1 really shines on tests that see how smart it is, especially when answering tricky questions. These tests are like big puzzles that schools use to see how well it thinks. It's really good at figuring out hard problems and showing its smarts, especially in things like science and math, which we call STEM. DeepSeek R1 got even better by learning in a big way, like getting more practice in a game. This practice helps it do even better than other smart tools, setting amazing new records. Looking at the graph, it's like seeing how fast different runners are in a race. DeepSeek R1, shown by the blue bars, is at the top for each test, like Amy 2024 and Codeforces. It's almost always standing higher than others. This means it's super good at being smart and quick, making it a champion in solving big questions. As we wrap up our explanation about R1, let's look at how making models smaller can actually make them better. Distillation helps these smart machines perform much better by keeping the important parts and making them lighter. If we check out the table, we can see different models, including DeepSeek R1's smaller versions, and how they do on different puzzles like Amy 2024 and Math 500. These smaller models still manage to solve puzzles really well, showing they're both smart and efficient. In the future, the goal is to make these models even better at speaking different languages without mixing them up. Also, they'll become more sensitive to understanding the right prompts, just like getting better hints in a game. Overall, this journey has been about making R1 smarter and faster at problem solving, ensuring it continues to grow and improve in solving various challenges.